Hi there, the unretired engineer coming at you again with engineering stories and more. So, when I started work, I actually started working for the US Navy as a civilian employee in 1982. I started as a lowly GS 3 at the Naval Avionics Center in Indianapolis, Indiana. It was my first full-time job, and I was fresh out of Rose-Hulman Institute of Technology, and there's a good reason they call it an institute, right? And I graduated into the worst STEM hiring environment in history. So that was one of the reasons I took a job with the Navy, but also my father had actually provided equipment to them, and I had worked with that equipment when over the summers, so I actually had some relevant experience that they could make use of. So I got a job, and I really enjoyed it for 15 years. But in that same year, 1982, Reagan signs a Small Business Innovative Development Act. And that act is basically continued to today with some modifications, changes. But it is a project, a program that I was involved in on and off for about almost 20 years. And I was involved from just about every side. I worked from the government side, and then later I worked from the supplier side as well. So I have some variety of stories to tell, things to talk about. So if you're interested in this kind of information and discussion on engineering and project management and society in some forms, please hit the like and subscribe, and you can even comment if you would like. So in the 1970s, 1980s, the federal R&D money was flowing, as you would expect, to large contractors. And there was some studies in the late 1970s, the one being the Rowland Report, which pointed out that small business were far more innovative in R&D dollars, but they were only getting about 4% of R&D funding. And so there was, a very poor mix, particularly if you were talking about innovative projects. And there was a very obvious problem, and part of the reason was the famous Valley of Death, where the idea works in a lab and prototypes work fine, but the problem is that though the solution and the problem are both real, getting beyond the lab demo into something in production is very difficult, requires funding that small businesses often can't get and really need partnerships. And that's one of the things that as the program started to solve. So Congress created a mandatory set aside for small businesses for innovative research. It was Small Business Innovative Research, SBIR. Most people who have worked in government aligned projects have heard of them, those in STTRs, which are more academic based. But those programs were set up back in 1982, and they were largely the same. So I was working for the Navy. I was a junior engineer. How do I become involved in a, $4 billion annual project? Well, essentially what happens is the SBIR office at the highest level of the government sends money down to essentially all of the others, and in particularly to the Defense Department, but also Department of Energy, Department of Transportation, etc. They all get a shot at it. But in the Department of Defense, then the SBIR office then basically breaks it out for the Navy, the Air Force, etc. And then in the Navy, that money went to the Office of Naval Research. Makes sense, right? But then they essentially say, okay, we have to get small businesses involved. They have to be problems that small businesses can solve. We don't necessarily have the experts. So what they do is they send a call down to all the naval facilities which have engineering and technical people, and they ask for topics. What would be a good topic that would solve a problem the Navy has that a small business could provide a potential solution, a technology demo for a relatively small amount of money. And then for a moderately larger amount of money, they could essentially go develop a real prototype, a practical prototype, a practical demonstration, and show that it really works so that they can then sell it to other companies. And the idea being the phase 1 concept, phase 2 proof, and then the idea is in a phase 3 effort, you would essentially bring the government, a contractor of some kind, and the small business together to essentially deploy that technology as a solution, or to essentially take that technology's IP and take it into industry where they can make it something. If it's a material, say, they can then develop that material into something that they can produce in quantity, with the idea that they would then solve maybe a commercial problem, and the government then come in and buy the smaller quantity. Or they would develop a piece of equipment that, again, would be broadly available, and government programs could buy that. And that way, you would overcome that valley of death and basically deploy this technology the government had helped sponsor. So, that was an ongoing thing. I was working for a branch, small business within the facility I worked for, that did microelectronics. And we actually had a 10,000 square foot class 1,000 clean room where we did what were called hybrid microelectronics, multi-chip modules, essentially, but using very small, very simple chips. I mean, this is the 1980s, right? But we were solving a lot of problems with obsolescence, and where a contractor had gone out of business, or where they had basically said, now we're not going to sell that to you any longer. And we got the data package, and we would build some number of units to support that project until the platform was eventually, taken out of service. So because we were doing practical work and work that was supporting a broad range of projects, we got a lot of calls for topics. And so basically every 6 to 12 months, we would get a call for topics. And, we would write up, we would have to think through and then write up a problem that could be demonstrated at relatively small amount of dollars, a couple of $1 million, in a year or less. And then that if it proved good, then, a few tens of millions of dollars would enable it to be taken forth, and it would be of interest to either a defense contractor or some industrial firm, that they could then take and commercialize the technology, could buy the company, buy the tech, or just support the company to develop the tech. So we got a lot of topics, and later in my career, I put in topics, and they were successful, and I managed those. Others I either saw or managed, even though they were topics I hadn't provided. So one of the key items here is very early in the SBIR process. Essentially, there was a very big success. And it came out of our unit. It was my boss predecessor had sent it in. And it's very simple in concept. Essentially, hybrid microcircuits are hermetic devices. That is, they keep out the outside atmosphere, so the device inside is protected from contaminants and water and whatnot. But once the lid is sealed on there, soldered or welded usually, it's very difficult to unlid it. And the problem was that the testing we did on circuits, or anybody does on circuits, doesn't catch everything, right? So once the circuit is lidded, finalized, and then put into test and evaluation, the fallout was relatively high, 10%, maybe sometimes higher, depending on the sets of devices and technology. And existing de-leading tools were hand tools and very crude tools, and they usually contaminated the product and you couldn't use it after it or destroyed the product. So phase one, very simple. We said, propose a technology which allows you to de-lead the widest range of shapes and sizes of hermetic by, remove, however you want to do it, get rid of the lid in a way where you don't destroy the interior circuit. So a company came to us and said, this is the solution. They basically demonstrated a single solution very well in the first, and they got the second one. And actually, the Naval Avionics Center got the first machine. And up until very late, in fact, and maybe even to the end, they were still using that machine 15 years on to de-lead. And that company was then able to take that demonstration, which the Navy had supported the tech. They also just helped write reports on the technology. They sold hundreds of these machines to all of the big defense contractors. And within a few years, I think 5 years after that, they showed that they were saving many millions per year, that essentially it was in the hundreds of millions already after about 5 years, because some of those circuits, they're built on very complex, they're very expensive, high yield, low yield is very, very impactful. So these things were saving money. Essentially, over that period, that one program had justified the cost of the SBIR program probably for several years. So one program, very high yield, kind of a VC type payback code. So, okay, that's the clean story. It's a very simple one. And there were a lot of other ones which were similar, right? There were also a lot where it fell at phase one or phase two was a great demo, but nobody ever took it up. Not a lot of programs ever made it to phase three, sometimes because they didn't really need to, and sometimes because just there was nobody to pick the technology up. But there are a lot of different, every success and every failure had its own story. But one of the ones, again, that we had sponsored was a machine that actually failed to solve the problem it was purported to solve. It solved it, but it solved it in a way that didn't really help. But the thing is that particular machine then went on, even though a very small number of them were ever built, they actually solved a big problem the Navy had, and again, paid for the whole program, probably in that for a year's worth of the project in that one program, even though technically it was a failure. So it's kind of interesting. SBIRs are a fascinating thing, and if you look at them from a cultural viewpoint, right, they're one of those things that in some ways people now complain about them because they have become, like all things humans, that they've been gamed, and they can sometimes look like they're not really doing a lot, but paying firms to go off and play around, but not really produce a lot. So there's pluses and minuses to all things. And a program which lasts for since 1982 is going to be gamed, and that's just the way it is. But I'm going to be coming at you with some more videos because I've actually been on all three. I actually created topics that I created, and I then became the manager of those topics, and some of those topics were somewhat successful. I was also later on the other side. I worked for a company that some people would have called an SBIR mill, though it really wasn't. But I worked and I proposed multiple SBIRs, and I took them through phase one and phase two, and a couple of them were looking like they might eventually go to phase three, though I wasn't there long enough for that to happen. So I'm going to talk about that, and we'll be talking about the program in general and the 2026 reauthorization and some of the problems and what some of the fixes are proposed. So I'll be coming back at you with all of that. So thank you for listening, and have a great day. Cheers.